I don't have this function, I don't have this function, I don't have this function. I don't care. I'm only asked to find dc over dt. So I will differentiate the left-hand side and differentiate the right-hand side. I'm going to copy it. So this is 150 minus x squared plus y squared equals c squared. And let's differentiate. Remember, we have here 3 functions of time. Do not get confused. X is not x. X is a function of time. Y is a function of time. C is a function of time. So x, y, and c. They have to be treated as functions. I'm ready. How do we differentiate implicitly?
Okay, so it'll be 2 times 150 minus x. And then plus, or no, times, wait.
Times 150 minus x.
Times negative 1 times dx over dt. So it's 150 minus a function, prime, to 150 minus the function to the first power times negative the function prime, which is negative 1 times dx over dt. This differentiated as all this, plus. I'm going to continue underneath because I don't want to hit that.
y.
Go ahead, guys.
Y dt.
Excellent.
2c dc dt.
That's it. Because this changes. If you don't like x, if x confuses you to think in terms of it being a function, use something else. Use w. I'm fine if we do that. Okay? But y is a function, c is a function. Okay. So I will simplify because all these 3 terms have 2 in common. So I will divide both sides by 2. So that will go away. And then I will divide by c because I only want dc over dt. And this is all at the top. So negative. So I can distribute here. That's better. Sorry. 2 is out. So I will distribute negative 1. So I have x minus 150 dx over dt plus y dy over dt. I have an expression for the rate of change of distance with respect to time. And now I can say, yes, that's fine. At this point, I can plug it in when I need it. Now, c, I have to take the square root from both sides to get c. So this one, so I have c squared equals 150 minus x squared plus y squared. This will be c is the square root of 150 minus x squared plus y squared. This piece is this piece. So I'm going to write it one more time. So x minus 150 dx over dt plus y dy over dt, and everything divided by this, which is c. The square root of 150 minus x squared plus y squared. At this point, I'll say I have the function, I have all the numbers, I'm going to plug them in. Okay, so what is this? How much is it? And how much is this?
dx dt is 35
That's it.
and dy dt is 25.
Very good. Now, remember what x was. X is the distance covered by A now in 4 hours. And what is y now? Only now I can use this, not before. Because if I use it from the beginning and I differentiate, I will always get 0. I will not have any variables. So be very careful. When we are asked to find blah, 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 when, you can forget about this till the last step of the problem. Okay. Unless we are told something is fixed. If we're told that in the problem, whatever is fixed, then we're going to use it. But right now, if it says, find the rate of change of the distance with respect to time between A and B, with respect to time, when, don't even consider that. Forget it till the last step. Okay, so now I have to consider it. I have to find X in 4 hours, and I have to find Y in 4 hours and put them in. So what is the distance covered by A in 4 hours, knowing that the speed is 35 kilometers an hour? What is the distance covered by B in 4 hours exactly, knowing that the speed is 25 kilometers an hour?
4 times 35. And
That's
4
it.
times
140. Very good. So this is 140. This is 140, right? And how much is Y? So in 4 hours at the speed of 25. How much?
So how did we get 140?
We have to multiply 4 hours times 35 kilometers an hour.
Oh, okay. Thank you.
Sure. So we find the distance equals rate times time. So how much is Y in 4 hours?
100.
100. Now we have all the numbers. Let's plug them in and calculate. 140 minus 150 is negative 10 times 35, negative 350. 100 times 25, so positive 2,500. Here, the same thing, right? It's 150 minus 140 is 10. Squared is 100 plus 100 squared. So I'm going to put everything in the graphing calculator. I'm going to share my screen, and here's the calculator. And I have in parentheses negative 350. Just making a point. I don't need to do this with a calculator, but I just want to make a point and remind you of parentheses. And again, parentheses, or not needed, sorry, because it's the square root. So the square root, and now I will use parentheses. 100, again, there is no need to do that, but it's, and 10,000. Close the parenthesis and enter. So 21.39, approximately 21.39. Measurement unit.
Kilometers per
Hour.
Excellent.
hour.
It's, yes, it's the rate of change of distance with respect to time. Awesome. Great job. So again, what did just happen here? We determined an equation. If the functions are related through this equation, their rates of change would be related somehow. What is the relationship between their rates of change? This one. So the functions are related through an equation. Their rates of change are related through another equation. But first we have to find this in order to find this. First we have to make sure that we come up with a relationship among those functions that we differentiate to get a relationship among their rates of change. Because they are related. They happen at the same time. And they are related as functions. Their rates of change will be related. Good. And as I said again, we have all sorts of different situations here. Okay, so where am I? I'm here. Okay, so we can now go back and look at anything. I like to look at a sphere, something with a sphere, because we already talked about it. A plane, a particle, again a particle. Okay, we are given the relationship here. We don't have to create a relationship. All these are given to us. The equations are given to us. What about the spotlight? Yes, let's take a look. Did you choose anything, or can we look at the spotlight? Anyone chose anything?
18 is fine.
Okay, very good. So let's take a look. A spotlight on the ground shines on a wall 12 meters away. Okay. I'm just drawing something that I imagine, and then we'll talk about it. And I can start from, if I'm in 2 meters tall, okay, walks from the spotlight towards the building. Okay. Unfortunately, I cannot draw a person. Sorry about that. But he's 2 meters high, or tall. Okay. The speed of 1.6 meters per second, fine. How fast is the length of his shadow on the building decreasing when he is 4 meters? When? So when you see when he is, disregard this till the end of the problem, okay? When 4 meters away. Okay, so I'm going to stop sharing. Good. So here is the spotlight on the ground that is 12 meters away from a wall. And this person started here and walks towards the wall. And look what happens. At this stage, this is his shadow. This is the length of the shadow on the wall. But when he is here, look what happens. This is the length of the shadow. And he is even closer. When he's getting even closer, then you will see it's even smaller. Okay, so the idea is this. And here's the person right here, walking this way. So this distance is 12. This is the distance covered by the person from the spotlight towards the wall. How do you want to call it? We have to use a name, which is basically a function, but we have to use a letter.
X.
Okay. And how do you want to call this, which is also a function because it changes? How do you want to call it, which is the height or the measure of the length of the shadow on the wall? Okay. So what are we asked to determine? Then I'm going to ask you what is this, and then what we're asked to determine. Do we need to read the problem one more time? Anyone? Anyone I haven't heard from, like Christine, I haven't heard from you. I don't think I heard from Ethan.
Can I phone a friend?
Say it again.
I just made a joke.
You can call a friend. Yes, you can call a friend. You can get any lifeline you need. So can anyone tell us what this is? Okay, let's read the problem one more time. A spotlight on the ground shines on a wall 12 meters away. Fine. If a man 2 meters tall walks from the spotlight toward the building at a speed of 1.6 meters per second, how fast is the length of his shadow on the building decreasing when he is 4 meters from the building? So this is a key word. Make sure we get a what type of sign?
Negative.
Good. So then what is 1.6 meters per second?
So velocity?
Yes. And what does it mean? What do I write based on what we have here?
That's how quickly X is changing.
That's it. That's all I want you to say. Dx over dt is 1.5 meters per second. What am I asked to find? How fast is the shadow changing at a particular instant? So what am I asked? What do I write here?
dy over dt.
Very good. Exactly. When x is,
4.
careful, 4 meters away from the wall. How much is x?
So 12 minus X.
Correct. Good. 4 meters away. When the person is 4 meters away from the wall, he covered the distance of 8 meters. Good. So we need the relationship between x and y. And here is my hint. Red and green. What am I telling you with this?
2X is
I'm telling you that these are similar triangles. The tiny red one and the big green one, they're similar triangles. And the notation is like this, similar. So red triangle, similar with green triangle. And you have to say, show me. What are you talking about? So triangles are similar only if I can show two congruent, which means equal, angles. Because if I show two, the third one must be the same. And I'll show you two congruent or equal angles. This one and this one. They are the same. And this one is a common angle. So therefore, these two have to be the same. No questions asked. If these two are the same and this is a common angle, these two must be the same. So I show that. Why is this so important? So what that they are similar? Who cares? Well, only because they are similar, we can write proportions with their sides. If they're not similar, I cannot write proportions with their sides. But the way I write the sides, the order I write the sides is crucial. So